Okay, so what we're gonna do is, hopefully everyone's downloaded Xcode by now, because that's what we're gonna use. So just pull up your Xcode. And then a screen might pop up. For me it doesn't, but basically all you need to do is click File, New, and then today we're going to use Playground. And let me just create this Playground. So then you want to just click, here I'll just go back. So you want to click Next, right, and create a blank Playground, so whatever is automatically selected. And then just, I'm just going to save this like L1 and save it wherever you want. So this is a playground. So basically what a playground is kind of an environment for you kind of to test out things, hence the name playground. So you can't build fully fledged apps in Playground. Next lecture we'll get into like building apps and using like Xcode. Well, you're on Xcode, but this is basically like Playground's a smaller version of the Xcode project. So here, this will be just a nice little area for you guys to kind of get used to the Swift syntax before we actually jump into building iOS apps. So one of the things that Playground does is it kind of automatically runs your code as you type it. I find that a little annoying because it kind of slows down development sometimes. So I'm gonna right click or just like click on this small little arrow and then click manually run. And you guys can do that, or if you like it automatically to run your code, do whatever. Okay, so you can see the.
Could everyone see that?
Yeah.
Can you make it
bigger? All right, yeah.
Preferences.
Good reminder.
Yeah. Just making sure so no one gets.
Yeah, no, it's just. Oh, should I go to presentation?
Yeah. Small presentation, small.
Small.
Yeah.
Okay. Okay. Ooh, everyone can see it. Good. Okay. Cool. Okay. So, kind of the first thing that I'll teach you guys is how to create variables. Variables are building blocks. You can kind of see one here, right? They're creating, you can do var string and it equals hello playground. So basically what's that doing? It's creating a variable called str of type string. And how does it know it's string? It's because you gave it a string literal. And then you can kind of see that Playground does a nice thing where it kind of tells you the value of your variable on the side. So pretty nice. Another kind of way to initialize a variable is let. So I'll just do netid equals this. And so let is a little different than var because with let it's a constant. You can't change what the value is once you initialize it. So with var string, right, I could do like equals, and then, but if I try to do this with this let variable, I just want to make it 1, 2, 3, and if you run it, it's a little slow, but you should get an error, right? And that's because with let variables, you cannot change them once you initialize them. So that's just the difference, and those are just two basic kind of variable initializations. And you can also, so some things, sometimes, I just declared like let equals string, like some string literal. So it knows that like netid is of type string, but you can also put type annotations if you want to kind of say, I want this variable to be of this type. So sometimes I might have a variable called full name, right? And it's of type string because a name is a string. So that's one, and you can also have like ints, and you can just kind of have whatever. And then if you want to, so now I'm like var month is of type int, and then maybe I want to assign it like 1 or something. So that's just like basic kind of how the syntax works, how we do typing. And then nice thing, you can also print stuff, so you don't really need, well, you can still do printing in Playground, but it does kind of show up on the side, so it's not totally necessary, but in development, you might need to print some stuff sometimes, so this is how you write a print statement. And then a really nice thing about Swift and what I like is how you can, the way you can put variables in your kind of print statement. So, for example, I might write a string called the month is, and then I want to use my variable month. And then this syntax of like the backslash, parentheses, close, and then another close parentheses. This is kind of how you put strings in lines. So you don't need to do the whole like plus thing that you might do in Python or Java. Yeah, and moving on. So that's just like basic printing. Might help you with debugging. And then a couple like basic data structures in Swift. You're probably familiar with arrays. Python and Java, they also have arrays. So to create an array, I'll just call it like var array. And actually I'll just call it like var lecture numbers. And I'm going to create an int. So this is how you create an array. So I'm going to say I want a variable called lecture numbers. It's going to be an array of type int. And alternatively, I could also do I can also put the type before, and then I can just make it an empty kind of. So this is a string for an empty like list literal. And also, I see that everyone's following along. I just want to say that you guys will post this lecture code online, but it's good that you're following along. But however you want to do it, we'll post everything online. Yeah, and then so one of the things you can also do is like add stuff to an array, just like so. So maybe I just want to like add all the lecture numbers in this array. So I'm going to start from 1, and I'm going to go all the way to 11, or I think 11. There's not 11 lectures. There's 10. So I'll do, and then if I want to add it, I just do like append. So that's that, and then if you like run it, you can kind of just see it go, and it's lecture numbers filled with like 10 numbers. So you can also modify things in an array. So kind of just how Python works, same thing, same zero indexing. Maybe I want to change like this lecture number to, instead of the zero number to be 1, I just want it to be 0, right? I just print out lecture numbers. So, and I'll print out lecture numbers before so you guys can see what it was before. So, yeah, so you can see that the lecture, you can just change things using the indexing. So it's pretty similar to most languages. If you want to remove stuff, like that's pretty easy too. You just do remove at. You can specify an index. Maybe I just want to remove like the 5th one. Or if you just want to remove the last one, there's a function for that too. So that's just like basic array manipulations. And this will help you guys for your project because the project definitely goes over this. And then a more interesting data structure, I would say, is dictionaries. So dictionaries, I think Python has dictionaries as well. And basically the syntax for that is pretty similar to create an array. Trying to think of a good dictionary to do. Let's think.
Lecture numbers to topics.
Lecture number topics? Okay, let's see if I know them. Yeah, so I'll do like, let me just call this dictionary lect num topics. And then, so then I'll create a dictionary of type int, and it's going to be a toString. And so as you can see, syntax pretty similar for array creation, for dictionaries, basically same thing, except you just put in the type of the dictionary that you want. So pretty cool. And then if you want to add things to your dictionary, so I'm going to add the first lecture, and I'm going to say that this first lecture is about Swift, maybe optionals if you have time, and Xcode. So, and then if I print out this lect num, and then I play it, prints it out. So, pretty cool. But it's kind of manual to just add everything using an index. You could just do a dictionary literal. So I'm going to create another variable, and then you can do, basically you can just do something like this, where you just use the colon symbol again, except you just put in the literals that you actually want in your dictionary. So 2, pretty sure it's going to be auto layout. So yeah, that's pretty much it. And you can also iterate over dictionaries. So yeah, the nice thing is you can iterate over key and value. So I'm just going to write key and value in let's do num topics 2. So, and then basically the first one's a key, the second one's a value. So print delect num key, and then let title value. Then we can also run that. Oops, classically have mistakes, but close it. Number topics, yeah, because I'm printing out the wrong variable. Okay, no problem. No, let's read errors more. Key. Oh yeah, right. Oh, you were right. Thank you. Yeah. Okay, cool. We got this running. Okay. So that's just like basic stuff, and then yeah, just basically this lecture is just gonna be me going over how to use Swift, because we used to do it where you guys like all just started off programming Xcode immediately. We found that everyone was very confused.
Does anyone have any questions so far?
Is there a way, like, does Playground allow you to just run certain sections of code?
No, not as far as I know. I think you just run the whole thing.
You could declare functions and then call the function calls. So yeah, you could wrap 7 functions.
Yeah. Do you have a question?
Yeah.
Do all the keys and values have to have the same type?
Yeah, all the keys have to be one type. All the values have to be one type. Yeah.
The way around that though, it's more complicated. But you could technically set your types as any.
Yeah.
But then you'll see later it's complicated. But technically you can't have like arrays of any or dictionaries of any to any.
Yeah, any matches like is any type, so that's one way around that. Yeah, okay. Does anyone have any other questions? Yeah? What, sorry? Oh, the warning? Are you talking about...
Because, yeah, in dictionaries, they're not sorted like an array. Arrays will always go from like how you type it, but dictionaries, they're not like sorted, so it's random how they're because they're hashed, I believe.
Yeah, hash. So there's not an order in dictionaries. So even though you put it in a certain way, it's not going to come out that way. Whereas a list, it'll come out that way.
Good question.
Yeah. Okay. Any more questions? Okay. Yeah. Okay. So we're going to go on to functions now. Yeah. So how you write a func? You're just going to write out func to start a function, and then I'm just going to write a function that's prints something. And so this is a function that takes in no arguments. And so that's why there's like that 2 parentheses there. And then I'm just going to print, hello world. And then you can just call the function, kind of just using the same syntax they used to write it. And so it's pretty basic. But if you want to have arguments, so maybe I want to create a multiply function. And so the way to write arguments is the same way that you may declare variables with types. So I would write the variable name first, and then I would write int, because I want it to be of a number. And I write a comma, because I want to have another argument. I'm going to write num2. And then I'm going to write another type, because it's going to be an int. So we're doing multiplication. And then to declare the return value, I have to do an arrow, and then write the return type, which is an int, because it's multiplication. And then within the function, I'm just going to write return num times num2. I'm also going to just change that to num1 just for nicer reading. So yeah, that's how you go. And then if you want to call it, so the nice thing about Swift is that they actually label your arguments. I know in Java they don't do that, so it's pretty nice because then you can actually remember, because you may not always remember what your arguments or parameters are. So, and then if I want to just maybe print out the result, so see. Yeah, so it's 2. Yeah, so that's kind of just how you would create a function and with arguments. And now we're going to move on to classes. And, oh, yes, question.
For functions, do you have to like explicitly declare the types of like inputs and outputs since you said that Swift is also like type reference?
Yeah, you do have to declare the type because that's kind of, I guess one thing I forgot to mention is that in order for it to do type inference, you do kind of have to give it some context. So you do have to say the type of the parameter, but yeah, good question. Does anyone else have any questions? Okay. Okay, moving on. So, okay, so so now we're going on classes, and we're also going to talk about structs a little bit. And so a class is just like any other class you've probably seen in either Python or Java. And in Swift, you just write class to declare a class. And this class I'm just going to call route because, or maybe I should call it, yeah, I'll just do a route class. Doesn't quite matter. Yeah, so I'm just going to call a class called route, and I'm on TCAT, and we just think about routes all day. JK. But yeah, and then if you want to create a kind of a variable, class of variable, you just do var, kind of just regular variable declaration, and then you say the type. I want a class variable number, type int. And then I'll keep it simple for now. The route will just have a number. And then, so like in most classes, you have some sort of initializer. And so the init will be, in this case, so I'm going to create just a custom constructor. It's going to take in a number because I want to fill in this number parameter. So I'm going to create this initializer, and I'm going to assign it. So I'm going to do self number equals number. And so now, self is kind of like this in Java. Can't remember what the Python equivalent is off the top of my head. Itself? Okay, so then should be pretty familiar with everybody. So self refers to the instance that's being created, and yeah, that's just how you create an initializer, how you create a class. Any questions before I move on to structs?
Someone's alarm's going.
Well, I have some reminders going off. Okay, nobody has any questions? Cool, because okay, I'm gonna do a struct. So a class is kind of like one type of way and something you're familiar with. Swift also has another way of, or another kind of like class, but it's not really a class, and it's called a struct. I'm going to create it first, and then we're going to talk about kind of like the differences between a class and a struct. So, yeah, so to create a struct, you will write struct, just like you create a class, you write class. You write the struct name, and then you can, so basically like kind of what a struct is mostly used to hold like data, and so usually a really simple struct would just kind of just have data variables, and that kind of like tell you what this is supposed to hold. So the bus stop, every bus stop will have a name. Could have other variables, but I'm just going to keep it simple from now and just do name. So, so a struct and a class are similar. They both, you can create properties, and you can also create methods in a struct and a class. I just didn't create any for you now, but you can do both. And they both can be extended. But the main difference that you should know between classes and struct is that classes are passed by reference and structs are passed by value. And so I'm going to go into an example, kind of show you the difference. But basically, like when you pass a thing by value, it'll pass like the reference, so when you pass a thing by reference, you'll be passing kind of like the pointer. And so when you modify that reference, you'll actually be modifying that object like somewhere in memory. Versus when you pass something by value, it will be like copied into a new thing, and then all the data will be copied into a new variable, and then when you modify that variable, it will like not be updated. Yeah, so let me just do the example because clearly you might have all be confused. Yeah, so let me just do this. So so do route. So if you want to create a class, you just gotta follow the initializer, right? So I'm gonna create a route. It's gonna be called route, and we're gonna just put in this constructor. And I'm gonna say this number is 40. And then actually I'm gonna create a var because I'm actually gonna modify it. Okay, so and then I'm also putting another thing, and it's gonna be called another. So I'm gonna create another route, and it's gonna be called route 2. And I'm gonna say route equals route. And then I'm also gonna and then I'm gonna modify route 2, and I'm gonna be like, okay, well I want route 2 to have a different number. I want it to be 30. And then let's see. So if I change route 2, I created route 2 based on route. So does route change? Let us find out. Okay, so I'm just gonna route is route.number, route number.
We should take a poll to see who thinks what.
Oh yeah, good idea. Okay, so let's yeah, too bad we didn't have the clicker thing. But anyways, so who thinks that route who thinks that this route number will be 40?
Raise the hands.
Okay. And who thinks it'll be 30? Okay, yay. Okay, I guess I sort of gave that away with my reaction, but yeah. So let's confirm, because we must always confirm in code. But yeah, just print this out. Yes, and so the reason for that is pass by reference, and what that means is that when you're doing route equals route 2 equals route, they're both actually pointing to the same object. So route 2 is pointing to the same object that route is pointing to. And so when you modify route 2, since it's still pointing to the same object that route is pointing to, then they're both going to change because they're both pointing to the same object. But now let's look at structs. Okay, so I'm going to create a bus stop, and I'm going to call it bus stop 1. And I'm going to put a name, and it'll be Baker Flagpole. So yeah, and then I'm going to create another bus stop, and it's going to be called bus stop 2, and it's going to be created based on bus stop 1. Okay, so then now let's take another poll. So who thinks? Actually, wait, I didn't even do the thing yet, so let me just do it. Oopsies, ahead of myself. Okay, so and then maybe I just want to change the name to like I don't know, another bus. Statler. Okay, Statler Hall. So okay, so now I'm gonna take a poll. So who thinks that bus stop 1 is gonna be Baker Flagpole? Okay, and who thinks that bus stop 1 is gonna be Statler Hall? Okay, so well, now we'll find out. Oh, very exciting. Yeah. So bus stop 1, do bus stop 1 dot name, and then bus stop 2. Okay, and why isn't it highlighting? Because I forgot something. Okay, so yeah, I guess I didn't need to print out both, but you can see both. So bus stop 1 is Baker Flagpole, and then bus stop 2 is Statler Hall. And so the reason for this is because bus stop is a struct. And when you're doing this, you're actually you can think of it like creating a whole nother bus stop. Basically all of the bus stop 1's values get copied into a new object of that that bus stop 2 becomes. And so that's why when you change bus stops 2 name, you don't actually change bus stop 1 because they're not pointing to the same object. So that's the key difference between classes and structures, and something that you should definitely remember because it can cause bugs in your code if you're not certain about the differences. So does anyone have any questions? Yes.
What's the point of the 70th line then? Like, why wouldn't you just do what you did in the 69th line again for bus stop 2?
Wait, sorry, which line? The 7th?
The 70th? Like, why wouldn't you just do the same thing you did for bus stop 1 for bus stop 2? Like, why would you refer back to bus stop 1?
So this is like a really simple example, but there could be instances where you're not actually doing this exactly. Like, yeah, you probably would never kind of do something like this. It'd be kind of rare, but like, say you create an array of like bus stops, and you pass this array around everywhere in your view control or in your app because everyone in your app needs to know about bus stop, like every view. So like, you may not be doing this necessarily, but when you query the array, like when maybe you have an array of like bus stops, and you query the array for like the 0 that's bus stop, like that's, and you assign it like var bus stop like 3, like you would, that's basically like you're passing a reference of the 0 that's bus stop to bus stop 3. That's just like, yeah, a simple example, but yeah, that's kind of how it would work. Yeah, does anyone else have any questions? Okay, we're at 8:09. Okay. Cool. And so now I'm gonna go over optionals, hopefully for only 10 minutes. I'm trying to get everything in because like the project kind of goes over optionals because optionals is kind of a different thing that you don't really see in the languages you may have seen. Like, well, I'm assuming everyone took Python and maybe is in Java. So that's something why I want to talk about it. And I do kind of talk about it a little bit in the project too. So hopefully you can get through optionals pretty fast, but we'll see. So like you're pretty familiar with, when you create a regular int, like its type. If you just write int, it's gonna be an int. Swift has also another kind of way to represent things, and this way is using the question mark. So you might see this a lot when you look up Swift code, and basically what this means is that an optional int is an int, but it is wrapped in an optional, and basically an optional can be nil, or it can have a value, and this value is going to be int. So you can think of an optional as like a box. So whenever you see the question mark, it's basically like a box around an int. And it's saying like, I may have an int in here, or I may not, hence the question mark. And it's kind of like, I'm not sure. And so that's, and so you can assign a value to an optional and to a regular int in the same way. So regular int's 1, an optional int also 1. But you can also give it a nil value because an optional is a box, and it can either have a value of its type, int in this case, or it can have nil. And nil is kind of a state to represent nothing. So it's kind of like null in Java and the equivalent in Python. Yeah. Is everyone following? Anyone have questions? Okay, I'm gonna keep going. And basically, so if an optional can have a value, right? An optional can be nil. Like you want to kind of confirm like what is the value. Like if you're using it, you want to know like, do I have a value? If I have nil, right, I should be doing something else. If I have nothing, I should really handle that case. So the way to kind of check one way to check it if an optional, has a value is you could literally do an optional int does not equal nil, and then you could be like, okay, print, so just print the optional has a value. But this is kind of not the nice way because you still, when you try to print out the optional, Swift won't really let you, and that's because they want to print out. So yeah, when you try to print out an optional int, they won't let you because it's an optional int of type int question mark, and they want to make sure that you're actually printing out the value. And because then when you give it a type question mark to print out, then they're like, are you actually printing out something or you're not printing out something? Please confirm. So, and a way to do that, to kind of unwrap your box that you've created, is to do an if let. And so I'm just gonna do that real quick. Optional int. And in this, you can see here that if I print out the int is, I can just basically, so now with this statement, I've said if there is a value in an optional int, bind it to this variable called an unwrapped int, and then print it out. So that's like how an if let works. And if an optional int was nil, so, and in this case it is, right, because we gave it a value of 1, and then we just reassign it to nil arbitrarily, then this statement won't be called at all. So, and you can kind of just see this if I just like play it, like it's not going to be printed. So yeah, nothing prints, and that's because it's nil. But if I delete this line, right, and so an optional int just has a value of 1, it'll be printed. So that's kind of like a nice thing about optionals, or at least the way optionals work in Swift, is that they have these constructs that basically allow you to work in a case where there is something, and then also it works in a case where there isn't something. It just fails kind of silently. Whereas in Java, you just might get a lot of null pointer errors. It's pretty annoying. So that's like some ways to unwrap an optional. I should probably get to Xcode at this point. Yeah, I think I'll do Xcode, but that's just like basic optional thing. And then there's other ways to unwrap an optional. If you guys want to like look it up, it's like guard let, and it's also there's guard let, and then there's like a Nilka Lacing operator. So if you guys want to look that up, you can. But this is if lets are basically like one way to unwrap an optional. Does anyone have any questions before I move on to Xcode?
Just so we're clear, like optionals are like a huge part of like iOS development, and with like every code you see, like optionals like you think like, why would I ever have a question mark? Like I know if there's an int or not. Like it comes into play like when you're like, oh, some routes might have a number in a description, but only some might have a description. That's like a great use for an optional, because then you're like, well, some might be nil, but some might have a description. And then if one has a description, you could maybe show it on the iPhone or anything. So like optionals are very important. So you guys make sure you understand that, because you'll see it everywhere and it's used all over iOS.
Yes. So hopefully you guys understand optionals. But yeah, you'll definitely encounter it. But right now I want to move away from Swift and just go into a little bit of how Xcode works. Or an Xcode project works rather, because we've been using Playground, but to create a real app, you would go to File, New, and then you would go to Project. So I'm just gonna go through just how to create a basic app, so you guys are familiar with this. So here you just see the screen, and you just kind of click Single View Application. In this case, and just fill out the name. I'm just gonna call it L1. This might be checked. It doesn't really matter. We're not going to be doing unit test or any sort of test or core data. So I leave them unchecked, but it doesn't really matter for this. And then you can just click Next. And then you just create it wherever you would like. I'm going to create it on the desktop. And so you'll see here that you have like a lot of panels in Xcode, kind of like how the Playground had panels. And that's kind of a characteristic of Xcode. But here you'll kind of see your navigation bar, and you can kind of just like go through the classes of your app. And these are just these files that you see are kind of what Xcode just provides for you. They're just like basic like files that you need to run a really basic app. Obviously, you'll add on to it more when you create your own projects. And you can just kind of, and here you just see a lot of information. You can search things here. You can see your errors here, pretty important. And you also have a bottom panel, and this kind of panel will be like the debugging once things go wrong. And this console will show bugs and show errors or whatever printed errors or anything that you print here. And then and this is just a side panel of other things. Like when you're on Storyboard, a lot shows up. But one of the things that we're going to move away from in this course is Storyboards. And that's because Storyboards are good for your basic apps, but they're not actually good for if you want to create a full-fledged like production-ready app. Like there's a lot with Storyboards, mainly merge conflicts that kind of can get in the way of development. Also, Storyboards can take a lot to render if you have a really big storyboard. So we're going to move away from that. And so the way I'm going to do it is just delete it. And I'm just going to move to trash because I don't want to see it. And then now I'm going to go into info plist. And now to tell the app, like, I don't want to run a storyboard, I want to run things programmatically. You just go to this key called main storyboard file base name, and then you just click the minus sign. And boom, it's gone. And then now, I'm just going to talk a little bit about how to kind of like launch an application programmatically. So an app delegate is basically a manager for launching your apps, and you basically just want to launch your app when your application did finish launching. So the nice thing about iOS development is they also the functions usually tell you kind of the state they're in or what happens. So for this part, there's a lot of boilerplate code, which I'm just going to copy and paste earlier and then just explain like what it's doing. So copy and paste this. You guys can either copy it down, but this will be posted, so no worries if you don't copy it down. But basically what a window is that it's a kind of a window into your application. It's the way you look into your application. And it's the highest thing in the view hierarchy. And so when you create your app, you have to create a window. Now you can see this question mark right in play, right? It's do I have a window? Do I not? And here you're going to be like, I'm going to give you a window, and I'm going to make this window the size of my screen, because that's all you want to see is your screen. Otherwise, you can't actually see beyond your screen. And the window needs a view controller, because a view controller, so window is like how you look into the app. A view controller is where you'll kind of manage your app, like how it works, like this button pressed, like then it'll pop this up. So that's what a view controller does. It just manages the views of your app. A window, you just kind of look in. So yeah, and then you just so you would set the root view controller of this window to a view controller. And here you can see I'm initializing a view controller, and I initialize this view controller, right, because I have a view controller called view controller here. And if we click on that, you can see it's of type UI view controller. So yes, it's a view controller. And then to kind of make your window visible, you just do this function, make key invisible. And to kind of prove that we're actually pulling this up, I'm going to change the view controller background to a color. Choose red. And then we're just going to play it. I'm doing the iPhone 8. And we just wait a really long time.
Yeah.
Then. Oh yeah, let me talk about the view lifecycle. So basically, kind of like how app delegate, they kind of tell you like, oh, my app finished launching, and then so you'll know that this function is called when the app finished launching, and at that point you should be creating or launching your app, right? Once your application finishes launching. View controllers also have a similar kind of functions. So in here, this called Viewdidload, and what that means is that your view controller manages a view, right? And after it finishes loading the view, it will call Viewdidload. And so usually you just That's why we just put all our like initialization of the view controller in Viewdidload, because once the view is loaded, we can put stuff into our view. We can manipulate our view. There's also like, oh, and then now we can see the app. So you can see the background's red. So it did launch this very simple app. And in terms of other like lifecycle things, there's also like view did appear. So this one, the view did appear, which is a little different from loaded, because your view may only be loaded once, but it might appear, right, if you go, you're like, if you keep popping the views, like kind of in the settings app, right, it may be loaded once, but it may appear several times, depending if you kind of go back in the navigation. So yeah, and there's also view like will appear, so sometimes you're like, you want to do stuff like, if the views just before the views gonna appear, I want to do something. So there's like a bunch of nice methods that are kind of part of iOS development or at least part of view controllers that are pretty good and pretty helpful. So yeah, that's like basic Xcode 101. This will help you probably for your next project, but I just wanted you guys to give you a little taste of how to start a project. And seems like I'm on time. So I'm going to quickly show you the Nilka Lacing operator. Then I'm going to go back to the PowerPoint. And I was going to go over enums, but I don't think we have time for that. And I think enums are pretty okay. I don't think I want to go over optionals because it's really the most kind of important Swift syntax thing and something really different that you don't see. Whereas case statements, you'll definitely see. And so another way to so I said you could do Garlet and you could do Nilka Lacing. So I'm going to go over Nilka Lacing, and that's one way to kind of provide a value for your optional when there is no value. Because sometimes you're like, okay, I know even if it's nil, I still want like maybe you're dividing by your number like maybe this number is like number I'm dividing by, and you don't want to divide. Just call it int, right? And maybe it will be like, yeah, it might be nil. But even if it is nil, you still want to kind of provide a value for that number sometimes. So you can do that by creating a variable called int with default value equals dividing, and then you can do double question mark, and then you're like, if basically this is saying like if this is nil, I'm gonna make it like I'm gonna just put this value for nil, and so it's pretty nice. This can be useful to kind of shorten your code, and you can kind of see that because so let me just print out unwrap default value. So the default value for nil variables is or optional variables is nil, so this will actually be nil, and which is kind of what we want because we want to kind of see this. So, and as you can see, it printed out 0. So that's like another way of unwrapping an optional. And yeah, does anyone have any questions? Okay, cool. Because now that we have 5 minutes left, I'm just gonna go over kind of like what you guys should be looking out for the this week. Where did I put it? In here. Okay, so I just wanted to go over like what you guys should expect for this week. We'll be releasing a project, and this will help you guys get you situated with Xcode. So let me just pull this up. Okay, so yeah, so these slides will be posted, lecture code will be posted, Xcode code will be posted, and just make sure you read the syllabus so you know what's up with this class, you know how many projects we have, grading, any other that concern. And we'll be releasing project 1 soon after lecture, and you guys should do that. It's a playground project, and it'll help you get situated with Swift. And don't forget to fill out the course credit survey. That's due Friday. Basically, I just need to gauge how many people we're going to add I just need to collect your emails or ideas or whatever to add you guys to CMS. And I also need to gauge how many people need paper forms to add so I can collect paper forms for you guys and then hand them out next lecture. And then also, please read the Piazza etiquette post and Piazza how to submit. yeah, we've definitely seen Piazza posts where people ask, general broad questions. It's really hard for us as core staff to answer that because we can't read your mind and we can't read your screen without seeing your screen yourself. So please read that to kind of make it easier for us to answer your questions and us to help you. And then just also read how to submit because we do want you to submit in a certain way and we don't want you to miss any files. So please read those posts and then I will see everyone next week.
Wait, also guys, before you leave, really quick, quiet down for a second. So the first project is due this Sunday, and if you guys don't understand it, please come to office hours. Don't wait till Sunday at 11 p.m. saying I need help on Piazza. I know we all do it, but try not to. There's going to be office hours Friday, Saturday, and Sunday. Come for an hour, get some help. And make sure you don't wait till the last minute. And next week will be more interesting because you guys know the basics now. So we'll be actually laying out views and actually interacting. If you have any questions, you can come up and thank you.
Okay. Awesome.
Sorry.
No, it's okay. Thanks for clarifying. So
if I actually added this for credit, is there a way to switch it, can I scratch it from editing?
yeah, as long as you drop before the 7 week 2 deadline. So just that's the deadline that you're working with, the 7 week 2. Yeah, so just make sure you drop before then.
And then, so basically me and a couple other people are going to use the library laptops, and they won't let us download Xcode because you have to update the OS and it won't let you do that. So I think we're going to try to do PDMing. Do you think it'll work?
And I've definitely seen people do it. It's possible. But I don't have any experience with that. So yeah, I would just look it up. It is possible. I've seen people do it though. Yeah. Okay. Yeah. Thanks. See you later. Yeah. Let me come over.
Individual because he's in Iowa. He's in your station. And he has to get more than 50% more than it'll put him not to eat. Yeah, I didn't imagine. So
It's not like this. Wait, guys, this is the glove I lost a few weeks ago.
Dude, this setup is like mad. What is this? Yo, wait. Dude, what is this?
iPad. We use it to go
Y'all are too much. It's so nice.
Wait, so do I just sub in this way and that's it?
I need to be
Yeah.
set.
What is that?
What is
so I got this whole setup from 255 to put it back.
Where does it go?
Just
Is
like
this
on the desk.
Xcode on the
Because this thing
iPad?
doesn't work. It makes you put it back.
Can you do that?